All right, we're going to prove that between any two roots of p, some polynomial, there exists a root of the polynomial q where q looks like this and p looks like this. And what you want to notice is that the derivative of p is in fact q. The n drops down to there, and then you subtract 1, and we do that for every term, and the constant term goes away, and we're just left with that. So we notice this derivative relationship between q and p, and that brings to mind mean value theorem and Rolle's theorem. And so what we're going to do is we're going to consider, first of all, prove that between any two roots of p, so we're going to establish two roots of p. Let x1 be less than x2 such that p of x1 is equal to p of x2 is equal to 0. So these are two roots, and like in previous problems, we'll establish that there's no root in between these roots, and for x between x1 and x2, p of x is never 0. Okay, and we want to show there exists a root in between those of the polynomial q. So we know we have this derivative relationship, and we have these endpoints that are both 0, so they're both equal, meaning we can invoke Rolle's theorem because we're dealing with polynomials, so it's continuous and differentiable. So since p of x is continuous and differentiable with their endpoints that are equal by Rolle's theorem, there exists a c that's between x1 and x2 such that p prime of c is equal to 0, but we know that p prime of c, which is the derivative of x at c, is just q. So this is equal to q prime of c. Sorry, this is equal to q, not prime, just q of c. Thus, q has a root between any two roots of p. That's the proof.